Hi everyone, I'm Jeff Sutcliffe to guide you through a presentation of our software for the statistical analysis of sailing weather forecasts. This is work with Chris Branning, Tom Beavers, Ubo Visser, and Riley Schutt. Chris will now explain the motivation for our work.
My name is Chris Branning, and like so many other navigators out there, I used to struggle with deciding which source of weather forecast to trust the most when crossing an ocean. There's so many different types of weather forecast grid files available to today's navigator, so it's easy to get lost in determining which grid source has the most accurate forecast prediction. Our software compares true wind direction and true wind speed captured on your sailboat's instruments, NOAA weather buoys, even NEMA data from coach boats, race committees, and personal weather buoys, and uses that data to statistically analyze the accuracy of weather forecast grid files. This allows the navigator to statistically verify which weather forecast grid file is the most accurate and why, while racing, on board, real time, anywhere in the world. When I sail offshore, I know I'm always navigating my team and our boat off the most accurate source of weather available. I've personally used it to set multiple course records, and I hope it's a tool you find helpful as well.
Our sailing software analyzes grid weather forecasts by comparing them to ground truth weather data collected from the instruments on your boat or from weather buoys. The software does a statistical analysis, providing correlations, errors, and calibrations that will align the grid to the logged weather data. An overall error value is provided with a recommendation of which grid most closely matches the logged weather data. This work is done in three phases: data preparation, the mathematical analysis, and results presentation. The software can be run from the command line or using a graphical user interface shown here. I'll focus on the GUI in this presentation. The GUI offers fields to parameterize and execute the analysis. At the top over here, information about the race, although it might not really be a race, is provided. The raw data panel specifies the source of the logged weather data, which can be log files output by the Expedition or Adrena navigation software, NMEA files, or NOAA weather buoy files. The location of the grid files to analyze is also provided here. The type of wind direction must be set to true or magnetic, and the anemometer height provided. This panel also includes a button to prepare the data in advance, which, among other things, provides the user constraints and the start and end times for the analysis. In the analysis settings panel, the weather components to analyze are set, chosen from the true wind speed, the true wind direction, and the barometric pressure. There are three analysis modes, and that's too much to explain now. It suffices to say that the default all grid runs mode analyzes all the grid files available. Most importantly, below that, the start and end time for the analysis are given with a granularity of how often to sample the data. The operation control panel is used to specify options for result reporting, and most importantly, contains the big Analyze button to start the analysis. Below that, there are options for getting help, the web pages, and updating the software. In the data preparation phase, the grid files and logged weather data are read in and prepared. The grid files are decomposed into comma-separated value files, .csv files. The logged weather data from Expedition or Adrena or NMEA or NOAA weather buoys is read in to extract data records, each containing the time of the data capture in UTC, the latitude and longitude, and the readings of the true wind speed, true wind direction, and barometric pressure. The weather data from boat instruments and weather buoys is often dirty because of the conditions under which it is collected. You know, those loose wires in the mast, electrical activity, etc. Therefore, the log data is cleaned to remove noise, remove plateaus and outliers, and optionally smooth the data. The analysis phase is the heart of our sailing software. Given an analysis mode and analysis time window, the grid file data is compared with the logged weather data. Various statistical measures are computed, including Pearson's and circular correlation, root mean square and average absolute errors, and the calibrations necessary to adapt the grid data to the log data. An overall error value is computed, which is then used to recommend one of the grid sources. The results of the analysis are reported as text, showing features of the grid data, as you can see over here for coamps and GFS, and the values computed in the analysis phase, shown over here, the correlations, errors, and calibrations. And at the bottom there, the overall error for that grid source, coamps. Down the bottom here, we see the recommendation to use coamps because it has the lowest error. The result data can also be plotted, the true wind speed, true wind direction, and barometric pressure. This is an example of a plot of the true wind speed. In black, you can see the logged weather data from the boat, and the other lines show the predicted true wind speed from the various grid sources shown in the key over here. Now I'll hand you over to Riley and Chris to talk about their use of the software in real sailing use cases.
I'm Riley Schutt from the US sailing team, and we use these statistical techniques to analyze the Olympic sailing venue in Enoshima, Japan, in collaboration with Chelsea Carlson from Sea Tactics. Over a period of 3 months last summer, we looked at wind data logged at 3 different locations. First being the public weather station on Enoshima Island. The second, we looked at our coach boat wind gear data on the actual race courses. And third, a beach weather station just to the north of the race course areas. On this particular day, it was really clear, and there's a great view of Mount Fuji in the background. Our goal was to look at which of 7 different grid file sources would give us the best predictions on the race course area. And really encouragingly, we see that grid number 2, which was our highest resolution grid source, gave us the lowest combined accuracy error relative to the data collected on the race course areas with our coach boat wind gear.
One of my favorite uses of the model accuracy sailing software was when we set a new course record from San Francisco to Hawaii in the 2016 Pacific Cup on a 100-foot Super Maxi. Using model accuracy, I was able to compare all the weather forecast grid files I had downloaded to our boat's logged wind instrument data and discovered the GFS weather model was clearly the most accurate weather source. I could also see the GFS was forecasting the true wind direction slightly right of what we experienced on the water and forecasting more true wind speed than what we were actually seeing. Then I was able to focus my attention on when to jibe using my top performing grid file, which I had even calibrated within the routing software for the exact air trends we saw in the water. The result was a new optimal route that encouraged us to dig further into the corner another 2 or 3 hours on already 1,000 nautical mile ley line. Arguing for hitting the corner even harder wasn't easy, but the data was there, backing me up in the middle of the ocean. We broke the existing course record by nearly 3 hours. Also, I was able to stop downloading other weather files via satellite that were underperforming, saving the team a considerable amount of money.
Thanks for watching this presentation about our software for the statistical analysis of sailing weather forecasts. With our software, you can go fast in the right direction using the right grid weather forecast every time. We're always developing new features, including input from Australian Bureau of Meteorology weather stations, multi-log analysis, and a grid optimizer that'll take a bad grid and make it into a good one. Visit our website, www.modelaccuracy.com.